Hello. I hope you all got a good rest, because you're in for a ride, because I did not. I woke up at 2:45. I could not go back to sleep. I didn't start drinking coffee right away, because I was like, maybe there's a chance. And about 4 o'clock, I was like, nope. So I started drinking coffee, and I didn't stop. So I apologize for that in advance, because I am vibrating. So, going to do a talk called I Can't Believe That Worked. It's kind of like stupid human tricks for computers, stuff that might help you getting a payload running onto a machine or getting a payload running. The slides will be available at redsiege.com/itworked. And I'll put that URL up at the end. But this is me. You already heard about me. Thing that I'm really focused on these days is the bottom part. So I like to take pictures. So if you like pictures, you can follow me, Hardwater Hacker, on like, not really on Instagram, but Threads and Blue Sky. So, all right, let's dive into it. This talk is for red teamers, but also for blue teamers, so that you can understand some of the things that red teamers are doing, trying to get stuff running on your systems. And the why is because, like, everything is stealthy until it's not, or you're being watched, right? So I just want to show you like some of the tricks that we use, some of which are really, really stupid. So this is a cat and mouse game. Like if you've ever worked on EDR Evasion, whoa, there's speakers here. What you'll realize is that when I first started writing like shellcode loaders to get my payload running, so my payload being like Cobalt Strike, for instance, the half-life of my first one was years. You know, it ran for years before I ever had to use another type of shellcode loader before it started getting detected. We now sometimes have loaders a new technique that works for weeks, and then it doesn't work, and so we have to tweak it a little bit. And sometimes the things that work, you bang your head against really complex problems, and then you do something like there's no way that will ever work, and it works. So I'm going to go through a few of those I can't believe that worked type things here. Every environment you're in is different. Like, you were like, oh, they're running CrowdStrike. Well, CrowdStrike can be configured in different ways. Sentinel-1. First time I went up against Sentinel-1, I did not know how configurable it was. Like, I'm just coming at it from an attacker perspective, and I could do anything I wanted. So the next assessment, I was like, oh, they've got Sentinel-1. This is going to be easy. And I got kicked in the face repeatedly. And so they're highly configurable, and those can have impacts on your results. And so sometimes you need to do one thing today, you need to do something completely different tomorrow. Nothing in here is really groundbreaking, but it might be new to you or to your team and worth knowing about. So this is the agenda. We're going to talk about a bunch of things. You'll see them, so there's no point reading them out. First thing I'm going to talk to you about is C2 channels. So C2 being command and control. So those are the channels that we use for communication for our implant, like Cobalt Strike or Brute Ratel or Nighthawk, things like that. So one way you can go about it is you can buy your own domain. And you can buy some domain, and maybe you tie that into something that looks like you think it's going to blend in with your target. And there's nothing wrong with that approach. However, when you buy a domain, a lot of security products, whether that is email filtering, link protection engines, whether it's web proxies, other things, they look at how recently has the domain been purchased. And if the domain has been purchased in like the last couple of days or the last couple of weeks, they're like, nah, I don't think so. The other thing is, when you stand up a domain, if you're a proxy vendor and you see a new domain, what are you going to classify it as? Unclassified. It's going to be unclassified. And most places block unclassified sites. They're like, I don't know what this is, so I'm not going to let you go see it. So you have to get your domain classified. And there's ways to do that. You can submit some of the proxy vendors and be like, this is totally a banking website. And most times they're like, yep, you're right, it's a banking website, and they allow it. But they're starting to clamp down on that. Now they'll be like, you have to have an account with us to be able to submit classification. And you might have multiple classifications you have to do. For instance, maybe they've got Proofpoint for mail protection, but they're using Blue Coat for web proxying. And those are different classification engines. I may have to submit to both of those vendors to get the site classified. So now, there's a lot of hoops I got to jump through. Do I really want to do that? I don't know. And even if I do all of that, I'm probably standing up my VPS in something like DigitalOcean or Vultr or Linode or whatever, which a lot of places are going to be like, you know, nothing good happens there. So no, I'm not going to allow that to happen. So what we prefer to do is to use legitimate infrastructure illegitimately. CloudFront. The world runs on CloudFront. If you run netstat on your Windows network, you are going to see a bunch of hosts calling out to CloudFront or to like AzureWebsites.net. Both of these are very easy to stand up what's called a redirector that sends your traffic from that site, say from CloudFront. All the client sees is CloudFront, and then CloudFront handles the plumbing back to my C2 server. So you don't, as an incident responder, you don't ever see where my C2 domain is. You just see CloudFront. And because everyone's using CloudFront, it doesn't look so suspicious. So you could do this. Other things you can do, Cloudflare workers. Cloudflare workers are great. Now you can have your own domain in Cloudflare, but again, you have the classification problem. Or you can use the free tier and use Cloudflare workers. The only downside is it routes through their workers.dev domain, which some people are like, that's suspicious. I don't know what that is, I don't trust that. There's also things like Microsoft Dev Tunnels. So from a client perspective, what you're seeing is traffic going out to the VS Code Tunnels website. And then from there, you run an agent on your C2 server that backhauls all the traffic over SSH onto your C2 server. So again, the client never sees where your C2 server is. They just see dev tunnels. Now the downside with dev tunnels is that they limit the total amount of data that you can run through in a month. So if you do what's called interactive mode in a beacon, where it's connecting back, real fast, like sometimes multiple times a second, checking for commands, and then maybe you're downloading stuff out of there. All of a sudden in the middle of a campaign, you're like, why isn't my C2 working anymore? And it's because you've hit the limit. So it works, but it's not, it's more like, I would say use it as like a persistence mechanism, a long haul thing that you don't need to use a lot. But it is stealthy. So now, we're gonna go on to bypassing Mark of the Beast. So Mark of the Web, anyone know what Mark of the Web is? Sign that something came from the bad place, just like Mark of the Beast. It came from the internet. It's a zone identifier in an alternate data stream that says this file came from the internet. And that is problematic because if I'm trying to phish you and I'm trying to send you a payload and you download it and you go to run it, Microsoft Smart Screen is going to be like, hey, this came from the internet. I'm not going to allow you to run it if it's a macro. If it's another kind of file, it's going to be like, hey, this came from the internet. Are you sure you want to run this? Are you sure? And sometimes that's not what we want to have happen. We don't want to have that kind of resistance that makes our target suspicious. So, the Mark of the Web is now applied to most file types you can download. You used to be able to do it with an ISO. You could send someone an ISO, they could double click on it, it would mount automatically. Well, now they know that the ISO came from the internet, so they won't mount it automatically. So now we have to find some other kind of container. Now there's tar archives, TAR, tape archives. And tar archives, if you download a tar file from the internet and you double click on it in Explorer, it'll say, hey, this file came from the internet. I don't think you should open this. However, if you are using the command line, you are HackerMan, and says you know what you're doing, and Mark of the Web doesn't apply. So all you have to do is build in a little social engineering into your campaign to get the user to run that command for you. And if that sounds like there's no way that's going to happen, go read up on how ransomware breaches happen. Because like some of the steps that users have to hop through to get the payload running, like these are the dumbest people in the world. they have to be. It's like, no, they're just non-technical people that like are really trusting. So you just have to build in a little SE. SSHing, or SSH-ishing, because we don't have enough ishing. We've got phishing, then we've got vishing, and then we've got smishing, and now we've got SSH-ishing. Don't blame me, blame intern Alex. Alex was the one who came up with this for us. So here's how it works. A .lnk file, a link, a shortcut, in other words, opens up a program, but it can also run a command line for you. SSH. SSH has this helpful option, -O, local command equals. You can also run commands remotely with SSH. You can say, over SSH, I want you to run this command on the target system. This one says, open up an SSH session, but I want you to run the command on this system, the victim's machine. So, if you can run SSH, you can run SCP, secure copy. It's a copy protocol that runs over SSH. SCP does not propagate mark of the web. So now we have a link file with a command in it that says SSH, but actually you're going to SCP this file from another system, and then you're going to run this command. And the command is going to be here. SCP this file from the attacker IP, so you do have to configure your system to allow this user to log in without a password, which is not ideal. Like in the normal world, we wouldn't do this, but we're attackers. We do bad security things all the time in the name of winning. So, you do this. Say, download this demo.doc. Why .docm? Because docm is a macro-enabled document. This is a Word 97 compatible document. It's still a macro-enabled document, but it doesn't have the .docm. And so things are like, cool, it's not a macro document. Save it in the user profile, because you don't even need to know where it's landing. User profile is a helpful variable that Windows provides for us. And then, and ampersand means also do this command. If this one completed successfully, open up demo.doc. So now we've SCP'd a macro-enabled document to a system. That document we copied over does not have mark of the web, so macro protections do not apply because there's no mark of the web on there. And now we have a payload. You do have a problem that the link that you send the user will have mark of the web on it, but you can helpfully talk your user into enabling that. And it seems to be a little bit less suspicious than like talking them for unchecking that on a Word doc. I don't know why. I don't know why. Maybe users are just aware enough of macro threats that this works better, but at any rate, you can read about it here, this blog. It's pretty cool. It's fun to do. Any questions so far? I got a lot of slides, and I added more slides last night, but I think I have enough caffeine, so we've got time. Stupid compiler tricks. We've talked about this before, so I'm not going to spend a ton of time on it. Compilers, they optimize code because we as humans really suck at writing code, so they make our code more efficient. They make it run faster, they make it smaller, they make it handle memory better. On the downside, they take your code and kind of distill it down into this block. So if you have written a block of code, and I've written a block of code that is similar, very similar, and the net effect is the same thing, there's a chance, if we're using the same version of the compiler, that the final code is the same for both of us. The machine code is the same for this function. So that means it's really easy to signature certain things. So, easy way of doing it, just disable compiler optimization. Now every time you compile, it will be a little bit different because it's not going to optimize for you, and it gets rid of some of those signatures. And that's all you need sometimes. However, there are certain things that still get detected, like this. I don't know if you say XOR or XOR. I'm going to say XOR. I like XOR. So this is a XOR routine for doing XOR encryption with a multi-byte key. It's very simple. You just iterate over the key length, or over the key, and when you get to the end of the key, you start at the beginning of the key again, and you repeat until you reach the end of your data. This is signatured by Defender. So you might want to do this because I did. Be like, I need to break this signature. So I inserted some random code. Let's declare some variables. Let's increment them and then add them together. So it's doing things. But because of compiler optimization, it looks at this and it's like, wait a second. None of this code matters. None of this stuff that's in yellow matters because it never uses the results of those variables. So therefore, I can compile or I can optimize them out of your program. Cool. It cannot optimize certain kinds of things out. So this, doing a printf, just open and close quotes, what does that do? Nothing. It does nothing. We're in C. I didn't include a new line character, so even if you're seeing the console output, it didn't scroll or anything. So I've inserted a printf, and the compiler says, hey, you're trying to print something out here, cool, I'm not gonna optimize that out. And so Defender thinks this code is okay. It thinks this is perfectly fine. Another way you can do it, literally just open the null device and close it. Notice I don't ever write to out file here. I just open the null device and I close it. And that's enough for the compiler to be like, cool. And now the code signature for this routine is different than this routine, even though they do the exact same things. The only thing I did was open up the null device up here and close it down here. But Defender doesn't recognize this because of that code that can't be optimized out. So that's something that you need to be aware of when you're writing code and trying to get it on a target system. We typically write our programs as console applications, meaning they open up a command window and maybe you see some output. And you can tell the Microsoft compiler to do that by using subsystem console. However, you can take the same program, you sometimes need to make a few minor tweaks and tell it that this is subsystem Windows, which means it's a windowed application, a graphical application, and the same exact code will not be detected. Now, sometimes it is, like this isn't like an absolute, you're gonna win doing this, but this makes a different signature because it's now in a Windows application, so it does different things behind the scenes, and then you just say, don't ever display the window to the user, because that would be weird if there's this window just opened up that's blank and not doing anything. And now, some EDRs like, cool, come on in. Some compilers make a decision about where something was compiled, or what it was compiled with, I should say, some EDR, sorry. Some EDRs say like, this was compiled with Pi2.exe on Linux. Therefore, this is bad. We've seen examples of this, of literally a one-line Python program that says, hello world, print hello world. Compile it with Pi2.exe, and I can't remember which AV agent it was at the time, detected that as malicious simply because it used Pi2.exe on a Linux system. Well, actually in Wine. It was running in Wine. Take that same exact code, use Pi2.exe and run it on an actual Windows system, and that same AV was like, cool, because it was compiled on a Windows system. So sometimes where you're compiling, and if you're a security person, you're probably hacker-minded, and so you're probably like, Microsoft, I'm never using that. Like, you need to get used to it because like sometimes it will make your life harder. Sometimes you just need to use the right tool, even if you hate the evil empire. Sometimes you have to use the evil empire's tools to defeat the evil empire. So, be aware of that. Sandboxes. Don't play in sandboxes. The worst thing as a red teamer is to have your code detonated in a sandbox. A sandbox is an environment that analyzes your payload, collects all kinds of data about what it is, and tries to make a determination whether or not it is safe to run before they allow it to run on a system. Or sometimes you'll see like if it gets detected, they immediately copy the payload over to the sandbox and analyze it. I do not want you as intrepid incident response people to analyze my payload and know what's going on. So I want to defeat you from doing that. So we can land in sandboxes in a number of ways. Someone gets suspicious about a file, they're doing threat hunting, they submit it for analysis. You also see it happen, like if you're trying to phish someone and has a link, click here to submit your credentials to register to win this $50 Amazon gift card. Because let me tell you, actually a $100 Amazon gift card, $100 is way more effective. Like, it will rain credentials and people will smash that link button over and over again to try to get the AWS or the Amazon gift card. And maybe that link delivers your payload. So whatever email phishing malware prevention engine they have running looks at that link, follows the link, says, oh, hey, it wants me to download a file. I'm gonna download it, I'm gonna run it. So now it's been classified as malicious before it ever got to the inbox. It might also happen, some AV and EDR will be like, I've never seen this file on a system before, I'm gonna scan it and see what happens. In fact, I'm gonna run it. We don't want that to happen. And what we really want to not happen is we don't want our payload being the Cobalt Strike Beacon or Nighthawk or whatever C2 we're using. We do not want that to run. The EXE can run just fine. We just don't want the EXE to launch our payload. So this is an example of landing in a sandbox. A couple of things about this stand out. The machine is called PSPubWS-PC. That on its own isn't necessarily suspicious, except that the username is the same as the host name minus the PC. And it's got this asterisk. In Cobalt Strike, that means you're running as like administrator privileges. Sandboxes want to run your payload with all possible privileges so they can see exactly what you're doing, because sometimes you only take actions if it's an administrator. So they're gonna run it as administrator. Then we look over here and like looking at the processes, there's really nothing here. There's no processes that we'd expect to see on a normal Windows machine. So that is also suspicious. So I don't want my payload to run here. So there are some things we know about sandboxes. They're usually very small. They have the minimum amount of RAM necessary, minimum amount of disk. They're usually using, they're pretty much always virtualized. There are some physical sandboxes that are out there, but you don't run into them very often. 800 by 600 video, one CPU. There won't be much installed, so you can do things like look at the size of the registry. What's the size of the registry and how many entries are in it? And take target systems that you want to run on, do a gold install, no programs, and say how large is the registry? How many entries are there in there? And then take a system that is fully provisioned, has all the programs on it that you've been using, things like that, and look at the size of the registry. It's going to be much bigger. So if the size of the registry is closer to the new install than an actual being used system, it's a good chance you are on a sandbox. So there's a repository out there called Check Please that contains code samples in a bunch of different languages that check for a bunch of things. Like, look for known virtualization drivers. Am I running in VirtualBox? Am I running in VMware? What's my DNS domain? Maybe you know the internal domain of your target you've gotten through OSINT. MAC addresses. VMs always have virtualized MAC addresses unless someone's really, really tricky and changes that, but I don't think people do that very often. How many processors? All kinds of stuff. So I talked about the registry, right? Like, build a baseline. How big is the registry on a new install? How big is the registry on this system? If they're close, nope out. But you probably don't want to nope out just based on one decision. Maybe you want to see is a user there. So users who use machines, if they just ran your payload, it means they're on the system. Like, payloads don't run on users' systems without someone triggering it the first time. So if they're there, they're probably moving the mouse. So get the coordinates of the mouse. Where's the cursor at? Wait a few seconds, get the coordinates of the cursor again. Has it moved? If the cursor never moves, there's not a user on that system. There's not a user on that system. But again, you don't want to make a decision about whether or not you should run on just one or two data points. So check a few different things. You know, look at, are you domain joined? Sandboxes usually aren't. Are you running as administrator? Most users these days are not running as administrator, and that's a good thing. We don't want them to do that. So do a bunch of checks and then decide what your risk threshold is. And if enough checks pass, there's enough checks that say, yes, I think I'm in a sandbox, +1, you reach some threshold, you're like, nope, I'm not gonna detonate the Cobalt Strike beacon that's running inside me because I'm in a sandbox. And if the number is lower than that, it's probably safe to run. Any questions about sandboxes? Yes? There's always that one guy. So the question was, wouldn't running these sandbox checks be themselves IOCs? Yes, they are. However, there's more than one way to do the checks, and like, you are more likely to fool a sandbox than you are an incident response analyst with those things. Like, an incident response analyst is gonna be like, wait a second. Sandboxes don't seem to be fooled by that from what I've seen. But that is a good question. That is a very good question. All right, don't blink. EDR has a maximum amount of time that it can spend looking at your process to decide if it's malicious. It can't wait forever. Users don't want their computers to be slow. They want them to be responsive, because what's the number one thing that happens, you know, like if computers start slowing down? The help desk blows up. Everyone notices it. So EDR cannot slow down the system. Systems only have so much RAM. They can't have an infinite database of signatures. So vendors are making decisions, what should I keep in my database and what shouldn't I keep? And so that's why we see some of these like stupid computer tricks come back in. And like, I've been around long enough, I've seen things that worked in the early 2000s, and then it was like, everyone blocks it because like no one legitimately in the world does that. And then because no one legitimately in the world does that, they removed the signature to free up some space, and now we can use that thing again. So if I can wait longer than the EDR can wait before I do something suspicious, there's a chance that I won't ever be seen, because some EDR, like, they'll stare at you for a really long time. They're looking. Ah, crap, I blinked. And now the EDR is out. It's got to go do something else. And if you didn't blink first, you stand a chance of running without ever being seen. Another one to point out here, like CrowdStrike. I'm not crapping on CrowdStrike. They're really good. But like, one thing they do, they look for new HTTP connections that originate from an unknown process within the first 180 seconds. So if you do not make a call out to your C2 server until 181 seconds, you stand a much better chance of surviving, because CrowdStrike waits. And if it doesn't see an HTTP connection, it's like, okay, I'm gonna lower the risk level. So we've established EDR doesn't have a very long attention span. So some of the things that we can do are, instead of copying our shellcode, like using Marshall.copy or RTL move memory or something like that, to move all of our shellcode into the memory that we allocate. If you're not familiar, like as a shellcode loader, if I want to run a Cobalt Strike beacon, I need to allocate space in memory. I need to copy that shellcode into memory, and then I need to execute the shellcode in some way, usually using something like create thread or something like that. So that's this pattern that has to happen. So instead of copying your shellcode in one byte, or one chunk, do it 1 byte at a time. You're not in that big of a hurry. That's not that many cycles. Just copy it 1 byte at a time. Or, you know, 10 bytes or 100 bytes or whatever it is. Just copy a little bit at a time. Maybe go do something else for a while and then come back. And delaying that time frame can make things work a little bit better for you. If you're interested, this is a link. I know it's tiny URL, so you don't know where it's going, because the link to this presentation that I got this tip from was like 3 lines long. Like, it's huge. But it's a really interesting presentation on EDR Evasion. It's from this guy that wrote this tool. Can't remember what it's called, but the title of the talk is like the first and last shellcode loader I'll ever write. It's about basically his his shellcode loader that he believes will last forever because of the techniques that he's using. So userland hooking. This might get a little bit deep here, but I'm going to try to not go too deep. So hooking is EDR looks at Win32 API calls. What's an API call? It's the way things happen under the hood. Everything you do has some kind of API call which then ties into the kernel to take an action. And EDR, true or false, EDR runs in userland or in kernel mode. Actually, that's not a true or false question. How many believe it runs in userland? How many believe it runs in kernel mode? You're wrong. There's a driver that runs in kernel mode, right? But the EDR itself, the hooks, live in userland because they used to live in the kernel mode, and then people started blue screening Windows systems all the time with their kernel mode drivers. Some of them still blue screen most of the Windows systems in the world on an average Thursday afternoon if you're CrowdStrike, but they got rid of that ability so that people couldn't crash every system in the world. So the hooks are actually running in userland. And my code is running in userland. And even though I'm not an admin, when I have code running in userland, I can do whatever I want in userland to things that are in userland in my process. So what EDR does is it looks at certain suspicious certain suspicious API calls, and it puts a hook in them. And so this is like your original function. So you're moving some data into EDI, and then you're pushing into EVP, right? Doing some move here, then the function code happens. That's the original function. I don't actually know what this function is. Like, I don't know. And then this is ret, like return to where you came from. So what they do is they put in a detour. It's called a trampoline. So instead of running these instructions, it says, go to here. And then what the detour does is it keeps track of the functions you wanted to do, does some inspection, and then eventually runs those and returns. That's essentially how a hook works. It takes what you wanted to do, takes some action before it so it can inspect what you wanted to do and make sure it's okay. So we can overwrite these hooks. However, overwriting the hooks is something that can be detected, and that is a tell. And there's different ways of overwriting the hooks, and some of them are easier to detect than others. There's a whole thing about syscalls, because like you've got API calls, and then you have syscalls, which are like down here calling into the kernel. You can call kind of kernel code almost directly, and EDR can't hook that. But doing that can also be a tell, right? So there's trade-offs all the time when you're doing this. So one thing you might want to do when I said take some time, the whole reason we talked about this is because you might want to take some time. And the easiest way to do this is to use this great function called sleep. Problem with sleep is that it's very frequently hooked because every malware author in the world wants to wait some time, so they call sleep. So what a hook does is says, okay, you slept. You never slept, it just jumped over the instruction. So now they can see what you wanted to do after a period of time. So there's different ways to do it. Calculate large prime numbers. Do something with the Fibonacci sequence. Maybe AES encrypt your Cobalt Strike beacon and only provide, you know, like 14 of the 16 bytes of your key. And then brute force the last 2 bytes of the key. That takes about 5 minutes on my work laptop, which is a powerful machine. That's a 5-minute delay that EDR can't hook because it's actively doing something. It's like, all right, you're doing some math, do some math. And some EDRs, that 5-minute wait is enough that they're like, I don't know what's happening. You could also check time, do an NTP call, and then do some computationally expensive things, and then check the time again. And if the times are exactly the same, you're in a sandbox. Someone's fast forwarding the events because in a sandbox, the time changes when they jump over sleep, the time doesn't change because they just made the future now. And so the time check now and the time check that you did in the future is now. I know, right? So I also may have had way too much coffee. So we talked about this before. Like, this is an old school trick. Take an executable and pad it with a bunch of data. Make it really, really big. because it takes a while to scan, and we don't want to slow down systems. So most AV and EDR have some threshold where if it is over a certain size, I'm not going to scan it. And some EDRs, I won't say who on video, but I will tell you afterwards, don't scan it if it's over a certain size, and then mind-blowingly, they will never look at your process again. I spent like 8 days trying to figure out call stack spoofing. And I am not the sharpest tool in the shed. And like, I am a just enough to get it done programmer. And that was like beyond my, like I could see where that knowledge was, and I knew that the amount of work it was gonna take to get to that knowledge was more time than I could afford to burn. And someone reminded me of a tool I wrote called DigDug. So, and if you got that, thank you, please, thank you. I appreciate that. It just makes a file bigger, and they're like, hey, I used DigDug the other day and it worked great. And I was like, so I ran it, and then I ran my red team for the next 4 weeks. My payload was never detected because once it was running, that EDR said, cool, it passed my checks once, I'm never looking at it again. I didn't have to do anything OPSEC safe afterwards because it literally stopped inspecting my process. Not every EDR works like that. Entropy, we've talked about this, it's a measure of randomness. When you encrypt things, entropy goes up because you make things more random. Check out Jargon, it's a really fun way of shellcodeless shellcode. The TLDR is there's 256 possible values for shellcode, 0x00 through 0xFF. Choose 256 unique words, map each word to a byte of shellcode, and then replace your shellcode in the loader with the word and store the dictionary in the loader. And then at runtime, you just reverse it and you'll get your values. And there's no shellcode in your loader, and languages aren't random. Go check out, there's links, there's videos. I talked about this, I think last year, so find out more. Speaking a different language. So speaking a different language, I don't mean French, I don't mean whatever. I mean like C, C++, C#. We write code in that all the time. And because we write code in that all the time, AV and EDR vendors have written heavy instrumentation to be able to see into binaries that are coded in these languages. And yes, you can do obfuscation. However, there is a lot of tooling to make it easy to understand what you're doing. If you ever tried to decompile like a Go or a Rust program, it looks like you've like opened a gate to hell itself. It's not so bad now, but like before, it's literally just like, I have no idea what's happening. No one knows what's happening. I can't make any sense of this. However, that doesn't necessarily like always work in your favor, being obfuscated. When I first tried to write a loader in Rust, I imported the AES crate, which is just saying I want to use AES encryption. And then I wrote a hello world program. Literally just printed out hello world, did no encryption. And Defender was like, you're using Rust, I don't know what's happening, and I know you imported the AES crate, get bent. And like wouldn't allow my payload to run when literally it just printed out hello world. So sometimes writing in another language can work in your favor depending on what EDR you're going up against. Side note, we've had really good luck with Python scripts lately. Not obfuscated Python scripts, like literally calling virtual alloc to allocate memory, copy the shellcode, create thread. The most basic, if you use this against any vendor, you deserve to get blown up. Function calls. And we've had multiple EDR vendors not see this because it was written in Python. They're like, oh, you're written in Python? Cool. I know nothing. Side note, embed your payload in a GIF image and pull it from a remote server. So now your loader is here and your shellcode is over here. Even more people don't see this. Now, sadly, just last week I was testing this, some are starting to catch on. So the game is afoot. We have to change our techniques again. A bunch of resources for learning in other languages. One, you should really look at this one, F#. It's another .NET programming language. It is funky, it is really, really weird. No one knows what it does, including AV and EDR vendors, and it is fully capable of writing a shellcode loader. So, I'm just saying, Time to go shopping. Go to the Windows Store. The Windows Store, frequently enabled on most Windows systems. How many of you are systems administrators or security people who prevent your users from using the Microsoft Store? Thank you. The rest of you, find out how they did it and do that, because there's no legitimate reason users need to go to the store. Like, they should go to the place that they're supposed to get software from. Because we can do things like install Python. If I can socially engineer a user into installing Python, and let me tell you, if you've ever had a chance to witness Jason on my team on a social engineering engagement, he can get anyone to do anything. He can talk them through loading the store, installing Python, downloading the Python script, and running it. He can get it done. Like, he's that good. And PowerShell. I'm pointing out PowerShell specifically because PowerShell by default on Windows has AMSI enabled. AMSI is the anti-malware scanning interface. So they created AMSI because back in the day, people were writing lots of malware in PowerShell. And if it was in PowerShell, it was a black hole. It was like, we don't know what's going on here. It's not compiled code, so we have no idea what's happening. So they created AMSI so they could look at your PowerShell scripts and your PowerShell commands and be like, no, you're doing something bad. I'm not going to allow you to do that. PowerShell from the store, which comes from Microsoft. So you're getting Microsoft's PowerShell from the Microsoft store, doesn't have AMSI enabled for some reason. Why? Why? I don't know. I don't know who made that decision. This is just the other day I ran this test. So this is the top one. This code doesn't do anything. It just contains the word AMSI. That's the thing. AMSI doesn't like the word AMSI appearing in anything you do. Like, you type the word AMSI in a string, it's like, no, you're trying to bypass me. So I'm not going to allow you to do that. However, PowerShell from the Microsoft Store says the term AMSI is not recognized as the name of a commandlet. It tells you that the AMSI is not enabled in PowerShell from the Microsoft Store. Why? I do not know. I wish I did. There's so many of these things, I'm like, who thought that was a good idea? I want to talk to that person. So this is the last technique. I believe we're on time. So this is called the divide and conquer technique. Divide and conquer, you should go read this blog. The link is at the bottom here. It's by this person called The Evil Bit. And once again, you can get the slides at redsiege.com/itworked. I'll put them in the Slack channel. You can hit me up. I'll gladly share the slides. So it's this concept of breaking up the workflow for a shellcode loader. So I have my program called divideandconquer.exe. And the first time I run it, I don't give it any arguments. So what it's going to do is get the target process ID. Now, that's configurable by me. Maybe I want to inject into Notepad. No, I don't want to run into Notepad because Notepad should not be making connections out to the internet. But maybe I want to inject into a browser, for instance. So I will get the target process ID for Edge. And then I'll allocate some memory in Edge. And then I'm going to call divideandconquer.exe from divide and conquer, right? And you can also inject into, like, get target process ID can be this. You can just inject into itself. It works this way too. Sometimes that's less suspicious. I don't know why, because it's technically remote process injection all the way, but it's less suspicious injecting into itself than it is another executable. So now I call divide and conquer, but this time I give it an argument, 2, give it the process ID that I just found by getting a target process ID, and then the memory address I allocated. I don't do anything else. So now the next invocation of divide and conquer, it runs, and it says, oh, hey, I got an argument 2. That means I need to go to case 2. So there's a big switch, case and switch statement, right? I'm going to open up this process ID that you handed me, and I'm going to write some shellcode into this memory address. But I'm not going to do anything else. I'm going to call divide and conquer with argument 3, the PID and the memory address. So now another instance of the program launches. And keep in mind, these 2 are still running, most likely. And I'm going to call it with argument 3. So now in the third invocation of the program, I am going to open the target process ID. I'm going to execute my code. Maybe I'm going to do it with create thread. Maybe I'm going to do it with QUser APC. There's a bunch of different ways you can execute code. Point is that I'm going to execute code. And I have done these all in different programs. Like from the computer's perspective, these are different process IDs. These are different invocations to the program. So one process did not do all of these actions. And because some EDR says, I have a very short attention span, I'm really bad at correlation, and these things happen across multiple processes, cool. Not everyone. I believe Sentinel-1 has had none of this nonsense ever since every time I've tried it, it's like, nope. No matter how many different ways I've rewritten it, it wants none of it. But this is what it would look like. So there's more going on behind the scenes, like because you're doing lots of this with like syscalls, and you're using a syscall skeleton loader, and that's a whole talk on itself. That's why it's doing things like what's my OS version, what's my architecture, all that stuff. But instance 1 says, hey, I'm identifying Notepad, getting a handle to Notepad, got process handle 752. And then it runs again, and it says, okay, I got process handle 748. Why the process handles are different, I've never understood that. Like this bit of code in the demo here, I don't know what it does. And I'm not too proud to admit that I have no idea what it thinks. In this case, get proc handle doesn't work like you think it would. Anyways, cool story, Mike. Instance 2, it moves some shellcode into memory, writes it, and it says, okay, I'm gonna run instance 3. Instance 3 says, okay, I'm gonna create remote thread in Notepad. And then, actually it's calculator. Well, the payload is popcalc. My payload pops up. So I executed calc. So this works because it breaks up the typical workflow that EDR is used to seeing. Allocate memory, copy shellcode, execute it. Happened in different processes, happened from, different programs because they're different instances of the program. This all happened in different places. EDR has a hard time correlating that, and so therefore, magic, like really. So to sum things up, this EDR evasion game is incredibly complex, except when it's not. And it's always changing. It is never the same. Like sometimes I wish I could go back to 2018 and my original MS Build shellcode loader that Chris Trunzer gave me. He's like, here, do this and put your code there. Don't change anything else. Don't change anything else. And it worked for like 2 years, year and a half, nothing. Now sometimes I'm like, cool new technique, just came out, try it, works on Monday, on Friday it gets burned. Like that's the reality in red teaming and evasion today. But that's a good thing. That's a good thing. I love it and hate it because I have to work really hard, but I love it because I'm constantly having to learn new things. And it means my clients have a lot better security. Except for when they don't, because EDR vendors were like, that's a bad decision, but I'm totally gonna do it. So, these are just part of the equation. Like, what's happening here for the most part is just getting your payload running. Everything that happens afterwards, except for instance where I said I made that program really big and then the vendor never looked at it again for the next 4 weeks. Like those mistakes happen sometimes, but most of the time what happens is my payload is now running. Everything I do afterwards has to be OPSEC safe. So if I want to run Bloodhound, well, Sharphound, and I want to run that data enumeration, and I'm running in an Edge process, Edge browser, CrowdStrike goes, why the hell are a bunch of LDAP queries coming from Edge? Edge shouldn't be doing LDAP queries. Boom, you're dead. Or if you're in a program that doesn't typically load the CLR, the common language runtime, and you try to run a .NET executable in memory, it has to load the CLR. And some AVs go like, you don't normally load the CLR. What are you doing? That's bad. Go to hell. I'm gonna kill your process. So everything we have to do after we get our payload running also has to be safe. This is just the first part of the equation. And that part of the game is constantly evolving as well. So if you want some training, there's some free training, good stuff here. If you want paid, I am not sponsored by Sector 7. But I cannot recommend them highly enough. It's like $250 a course. It's amazing content. Be aware that it's only good for a year now. It used to be perpetual. Now you only have access for a year. Maldev Academy, this company called Red Siege does training at places. If you want to go to Black Hat, we might be there again, and we could teach you some stuff. We teach other courses too. White Knight Labs has amazing training. 0 Point Security, amazing training, amazing courses. So hit me up on Discord. redsiege.com/Discord is where you can find me a lot. I'm Hardwater Hacker there. We have this thing called the Wednesday Offensive. Every Wednesday at 12:30 Central Time. Starts promptly at 12:30 Central Time. Pre-show banter starts about 10 minutes before that, and we end at the top of the hour. Interesting people doing interesting thing in the security space. No slides, no BS, just cool chat. LinkedIn, I accept LinkedIn requests from everyone. This is me. If you like pretty pictures, this is also me. And ideally, the slides should be at redsiege.com/itworked. However, if they're not, there's multiple channels you can get a hold of me, and I will dump them in. We have a Slack channel, not Discord, for this conference, right? Yes, I will put them in the Slack channel. So that's it. Questions? Thank you.